Thank you for logging on to our web broadcast for the model 6040 and the optical plug-in modules. My name is Robert Corsetti. I'm with Berkeley Nucleonics, and I'm also with my colleague, Mr. John Monks, who's our senior analog engineer. And we're going to discuss briefly a few of the features and, again, the electrical and optical plug-in modules. And John, do you want to just briefly talk about the electrical module and more or less with some delays?
Unique electrical outputs have modules which will put out plus to 50 ohm. We also have modules which will put out transition times of 50 picoseconds, and with variable baselines anywhere from plus or minus 5 volts.
Great. I know a lot of customers talk to Berkeley Nucleonics over our 45-year-old plus history on these modules, and the 6040 has been around how long now, John?
The 6040 has been around since the almost at the beginning of the 90s.
Well, this product's almost 20 years old.
Yes, many years old and very, very reliable. And most of the ones that have been sold are still there in the field, still being used.
Excellent. The 6040 does a lot with our optical and electrical customers. John just spoke about the electrical modules. John, how did the optical modules benefit our customer base?
The optical, you can put out 50 milliwatts at pulse and up to 2 kilohertz, and then we have CW modules which will put out 5 or 10, or some will go up to 20 milliwatts CW laser light, and they range everywhere from 650 nanometers to approximately 1700 nanometers in wavelength. So it crosses a big spectrum of light.
That's a huge spectrum, and a few of the cables that you see in front of you, BNC offers a couple connector types, John.
FC, ST, SMA, and if a customer wants something other than that, we can accommodate him.
Excellent. I know a lot of the optical connectors now are usually SC connectors, but it's good to have the capability in providing systems like SMA connectors and C connectors. One of which is the ability to swap the mainframe, and you can swap electrical and optical module an output signal to drive laser systems. That they can also do that as well, can't they?
Yes, in fact, it's very flexible. It's basically a laboratory type you can put on your test bench. It does have RS-232 and GPIB capability, so it's very convenient for automatic testing of desire for computer programmers. It gives you a rep rate anywhere from about 0.01 hertz to 100 megahertz. Good for the optical modules and the electrical modules, and many, many other features. Gives you precision or near precision pulse widths and near precision pulse delays. It will give you double pulse and many other things.
Correct me if I'm wrong, you can change the width delay on the output pulse on the optical and electrical module, correct?
Yes, you can change the delay anywhere from about almost 0 nanoseconds all the way up to about 640 seconds. So that's a huge delay range. And you can have double pulses if you can have an initial pulse and a delayed pulse all the way out to 640 nanos. All this stuff is controlled through GPIB and RS-232 in case you want to automate your system.
Is there any reason why the GPIB when compared to RS-232 port?
It would be mainly out of convenience. GPIB in some respects more stable than RS-232.
Right. The GPIB has been the standard for quite some time, but we see customers using the RS-232 with USB connectors as well. But it's good that we have this this lineage from the GPIB port talking to established laboratories. Is there anything else that we'd like to talk in regards to programmability, John? Do you feel there's any requests that kind of stand out in your mind on programming a box? It's pretty much easy to use.
You can store many settings, pulse modules. You can set it for precision delay or width or precision or particular amplitude, and store those settings if you so desire. And if you want to program this thing, or program it as a programmable pulse generator, you can do that with your PC, do that through your RS-232 and GB, and do it in real time.
Excellent. One of the many features that we offer with the 6040 optical module, the flexibility of our laser diodes. We offer many different power settings up to, I believe it is 100 milliwatts, and again, like John stated, wavelength it ranges from about 600 nanometers all the way up to 1580 nanometers wavelength of light. And we standard with the 6040 opticals, either single mode fibers or multi-mode fibers, depending on the application. So make sure to check and see myself or John when inquiring about the 60 optical modules or electrical modules. All right, John. Another great feat is the ability to handle incoming and outgoing trigger signals. So if you could just take a brief minute and explain the ECL out, the trigger in and out, that'd be great.
It does have normal ECL out at 0.8 volts and negative 1.8 volts. External trigger, accept anything from plus 2 volts to negative 2.5 volts, continuous all the way in between. It does have a trigger.
Is there any particular reason why I use a trigger in or a trigger?
Well, we don't know what to cut with, so it's very, very convenient to have a machine which will accept almost anything as a trigger. It will adjust anything from plus to minus 0.5 volts. So that's a big advantage to some customers.
Oh, great. And the ECL out again, would any customer have a particular reason to use an ECL out? Is that also a broad specification?
It's a broad specification. The person wants to trigger, has a circuit board in it, then he will want to feed an ECL signal, which this thing puts out. And as normal ECL, you can run a normal ECL chip 6040.